You listening. I really admire your thirst for knowledge. Hopefully I can quench that for you with further explanation. This is part 3 for gathering information, and I can only conclude that if you are still with me, then not only do you not find this boring, but you find it very interesting. I commend you on your enthusiasm and interest. So here we go, part 3, low voltage programming of 8-bit PIC devices. There are 2 modes for programming a PIC microcontroller: high voltage HV mode and low voltage LV mode. The low voltage programming LVP mode allows the PIC flash MCUs to be programmed using the operating voltage VDD of the device. This offers many advantages to in-circuit serial programming designs. A new PIC device will have the configuration set to LVP mode when purchased. Any of the microchip development tools can program the device using the LVP method. Many of the latest development boards, such as the Curiosity board, use the LVP mode for the built-in device programmer. LVP configuration setting. When the LVP bit of the configuration registers is set to 1, the low voltage ICSP programming entry is enabled. To disable the low voltage ICSP mode, the LVP bit must be programmed to 0. Typical LVP configuration register layout. U1, RW, read write 1, U1, and so on and so forth. LVP, low voltage programming enabled bit. 1 equals low voltage programming enabled. mClear VPP pin function is mClear. 0 equals HV on mClear VPP must be used for programming. The LVP bit cannot be written to 0 while operating from the LVP programming interface. The purpose of this rule is to prevent the user from dropping out of LVP mode while programming from LVP mode, or accidentally eliminating LVP mode from the configuration state. The LVP bit can only be reprogrammed to 0 by using the high voltage programming mode. LVP mode. Entry into the low voltage programming entry mode requires the following steps. Number 1, mClear is brought to low logic voltage level, VIL. 2, a 32-bit key sequence is presented on the ICSP DAT pin while clocking ICSP clock ICSP CLK pin. Once the key sequence is complete, mClear must be held at VIL for as long as program verify mode is to be maintained. Any of the microchip programmer debugger tools handle this setup through the MPLAB X IDE. Older 8-bit devices have a PGM pin that needs to be set to a logic level externally. Refer to the datasheet of your device for the correct LVP method. mClear operation in LVP. mClear is an input pin that can reset the device when it is enabled. The mClear pin can also be configured as a standard digital input-only pin. The mClear E configuration bit enables or disables the mClear pin. mClear E, it's got an X. Okay, so if it's X and 1, mClear is enabled. If it's 1 and 0, it's enabled. If it's 0 and 0, it's disabled. If LVP is enabled, LVP equals 1, like it is there, the mClear pin is automatically enabled. So it doesn't matter what you write here, and cannot be disabled. mClear enabled. When mClear is enabled and the pin is held low, the device is held in reset. The mClear pin is connected to VDD through an internal weak pull-up resistor. mClear disabled. When mClear is disabled, the mClear pin becomes a digital input-only pin and can have an internal weak pull-up resistor through software control. mClear weak pull-up. The mClear digital input-only pin has an individually controlled weak internal pull-up resistor that is connected to VDD. A bit in the weak pull-up WPUXX register enables 1 or disables 0, the pull-up, when in digital input-only pin mode. There is also a configuration bit mClear E that will enable 1 or disable the pull-up when the pin is set to mClear mode. When the LVP mode is enabled, mClear E equals X and LVP equals 1, the mClear internal pull-up is enabled and the digital input-only weak pull-up resistor software setting has no effect. Return to the top. So that has been the low voltage programming of 8-bit PIC devices. Now I opened up some separate windows or tabs. Well, it's debatable as to whether I should read this. This gets outside of the order of the instruction series, but I guess I can flash it on the screen here. So for low voltage programming in real ice, here's the curiosity board. Well, I will read this because I actually think that since when you go to program your PIC chip, every time you're basically going through the ICSP, this is probably important to know. In-circuit serial programming considerations. A debugger, emulator, and programmer use a serial signaling scheme to program a target device in circuit. A debugger and emulator use the same scheme to debug a target device in circuit. The signals utilized are the clock and data signals defined in some data sheets as PGC and PGD, or ISPCLK and ICSPDAT. Additionally, mClear VPP is used as either a high voltage programming signal or an attention indicator to the device. These signals are not dedicated for programming and debugging only, but are shared with a port pin or alternate peripheral. Generally, most devices use ports RB6 and RB7 as the default primary ports. For trouble-free in-circuit programming and debugging, you must plan carefully to avoid any problems during application development or production phase of the product. The proposed implementations are discussed in the following sections. Recommended ICSP implementation configuration. The signals PGC and PGD are active bidirectional signals driven by the tool and target device during a typical programming or debugging session. These signals follow the programming specification and device algorithm. To minimize programming times, the signals are clocked at a fast rate of speed. Any additional obstructions or loads can distort the signals sufficiently enough to cause either intermittent or hard failures and prevent programming. Keep these signals free of any other passive circuits or active logic in the application. It will ensure trouble-free debugging and programming sessions. Another benefit of this configuration is that cable length and/or type may be negligible, as there will be fewer reflections from cable mismatches. Additionally, the mClear VPP signal is used by the development tool to provide the voltage used for programming some devices or to signal attention. In instances where the application has a large capacitor, it will cause the signal rise and fall time to degrade. This will hinder the ability of the tool and the device to communicate effectively. It is recommended to keep the signal pulled up to VDD with a 10K resistor and to utilize the power on timer features of the device to ensure a proper power up sequence. The ICSP power connection from the tool to the target device assembly must use the operating VDD voltage of the device, not the system. For example, if the system voltage is 5 volts but the device voltage is 3.3 volts, then the ICSP power connection should be 3.3 volts. A matching operating voltage is required so that logic levels remain compatible between both the development tool and target device. Alternate ICSP implementation configuration. In some cases, especially with low pin count devices, the pins must be utilized by the application. If this is the case, a minimum resistive isolation is required between the device and the application active node. This will ensure that both the application circuit and the development tool are able to drive the programming pins, PGC and PGD, to ground and to the proper VDD levels. The figure below depicts this configuration. Figure alternate ICSP application circuit. The resistive isolation value will differ depending on the application and how it is being used. Values ranging from 1K to 10K are suggested. In any case, ensure the levels on PGD and PGC can be driven to their appropriate logic voltage levels. For isolating mClear VPP, especially when the application uses a voltage supervisor, refer to technical brief TB087 DS91087 for an in-depth discussion. Okay, so I had to zoom in on the browser to catch this. I couldn't open it in a new tab. Isolation circuitry, register or Schottky type diode. Note, isolate programming signals from application circuit. Note, if unable to isolate mClear on PCB, use series resistor here to help prevent excessive overshoot. Oh, that thing disappeared, whatever that was. ICSP programming header. Target microcontroller device. Typical values. Where's the asterisk? I guess that's here. This was kind of covered already. To application circuit. Connect MPLAB ICD3 ICSP program header.